Here we go. Boys and girls, Mr. Trutna here, Clovis High School. We're going over Math 2, Unit 4, Worksheet 4, medians and altitudes and various points that we have. Mr. Trutna here, what's going on? All right. Okay, let's get going. Number 1, line C to D, CD. Line CD is a what of A to B? Well, if you notice, where CD intersects AB at, we get a 90-degree angle, so that makes it perpendicular, and we'll use the symbol for perpendicular. And not only do we get a 90-degree angle, but we have these congruent marks saying that D to A is congruent to D to B, so that makes D in the middle. So that means CD cuts A to B into two equal pieces. That's called bisect. So C to D is a perpendicular bisector of A to B. How do you know something's a perpendicular bisector? Well, if you see two line segments or lines that cross, if you see the 90-degree angle and you see the congruent segment marks, that means we have a perpendicular bisector. So when we go to number 2, point K is the what, the blank of the triangle. So here's point K. Well, if you notice, point K is the point where this line intersects with that line, which intersects with that line. So it's the point of concurrency of those three lines. And what are those three lines? Well, if you notice, each one of these lines, this one has a 90-degree angle, and it has the congruent segment mark. So it's a perpendicular bisector. So point K is where the three perpendicular bisectors meet. So what's that called? That is called the circumcenter. The circumcenter is the point where the three perpendicular bisectors meet. It's called the point of concurrency. Okay, point P is the blank or the what of the triangle. So point P, this is kind of weird because P is off to the side, but we're actually talking about that point right there. Okay. So you can see that point P is where this line segment intersects with that line segment and intersects with that line segment. So it's the point of concurrency of those three line segments. Well, what kind of line segments are those? Well, let's talk about what they are. Okay, so if you notice, let's just focus in on this line segment, and then we'll see if it applies to all three. So this line segment starts at a vertex of the triangle, a corner of the triangle, a vertex of a triangle, and it goes to the opposite side so that it makes a 90-degree angle. So that means it's perpendicular. So what's the name of a line segment that starts at a vertex, goes to the opposite side of the triangle, and makes a 90-degree angle? That's an altitude. So, and if you notice, all three of these line segments start at a vertex, a corner, they go across the triangle to the opposite side, and they always make 90 degrees. So we have three altitudes. So where the three altitudes intersect is called the orthocenter. So point P would be an orthocenter. Okay, we just answered the question to number 4. The segment shown is a what? Well, that would be an altitude. How do we know that that segment is an altitude? Well, because this segment right here, it starts at the vertex of a triangle, it goes across the triangle to the opposite side, and it's perpendicular. That's an altitude. Number 5, let me move this up. Number 5, point Q is the what, or the blank, of the triangle. So here is point Q. And if you notice, point Q is the point of concurrency of that line segment, and that line segment. Okay, so what type of line segments are all three of these? Well, if you notice, let's just focus in on this line segment, then we'll see if it applies to all three. This line segment starts at a vertex of a triangle. It goes across the triangle to the opposite side, and it stops right here. And right where it stops, that's in the middle. That's a midpoint. How do I know that? Because of the congruent segment marks. So this is a median. A median starts at a vertex, goes across the triangle to the opposite side, and stops in the middle. Let's see if that one does it. So this line segment starts at a vertex, goes across the triangle. Does it stop in the middle? Yeah, it does, by the congruent marks, as does that one. So the point of concurrency of the three medians is what is known as a centroid. Okay, so we just talked about a median. That's the answer to number 6. This segment is a median, M-E-D-I-A-N. And the reason why it's a median is because this segment starts at a vertex of a triangle. That means a corner of the triangle. It goes across the triangle to the opposite side, and it stops in the middle by those congruent marks. Okay. Number 7, point W. Here's point W. It's the what of the triangle? Well, if you notice, it's the point of concurrency where that line segment intersects with that line segment, which intersects with that line segment. Each one of those line segments, as you can see, they create 2 equal angles. Each one can create, so these are angle bisectors. So the angle bisectors meet at a point known as the incenter. So that would be your answer to number 7. Okay, number 8, what is the distance formula? This is a formula that you should remember. Those who remember it tend to do a little bit better when they're instead of having to look it up. So the distance formula is the square root of the second x value subtracted from the first x value. Then we put that to the power of 2, or the second power. Then we add to that the second y value, subtract the first y value to the second power. Okay, so some math teachers say the distance formula is the square root of x2 minus x1 to the second power plus quantity y2 minus y1 to the second power. Okay, the midpoint formula involves these x1s and x2s and y1s and y2s, but it's a little bit of a different formula. The midpoint formula is the first x value, x1, plus the second x value, x2, divided by 2. Then you put a comma because the midpoint formula gives me a point, so I'm going to have an ordered pair. And then it's the first y value, y1, added to the second y value, y2, divided by 2. That's the formula we use for the midpoint. Okay, the slope formula involves these x1s and x2s, but the slope formula is it's a fraction. Remember, we always represent slope as a fraction when we can. And just to review, the letter m, lowercase m, is the letter that we use to signify slope in a math class. Okay, and the slope formula is the second y value, y2, minus the first y value, y1, over, so that's your numerator, then your denominator is your second x value minus your first x value, y2 minus y1 over x2 minus x1. So these 3 formulas you'll need to know, and you should start memorizing them. And basically the easiest way to memorize these 3 formulas is that every time you do a problem involving a distance formula, just start the problem off by writing down the formula. Same with midpoint, same with slope. If you write it down enough, you'll just naturally remember it, so you won't have to spend time stressing out over it, making flashcards or whatever, and remembering it. All right, numbers 11, 12, and 13. We want to explain why MN, so why line segment MN, and in number 11 we want to explain why it is a median and altitude, or if it's neither. Okay, so here's M to N right here. So let's talk about, so where does it start? Well, it starts at M. M is a corner or a vertex of the triangle. It goes across the triangle to the opposite side. It stops at N. And if you notice, N is in the middle. So that means 11 is a median. Okay, M-E-D-I-A-N. Now, explain why is it a median? Median because starts at a vertex, ends at the middle of the opposite side. That is how we defined what a median is the other day in class. So I'm just like regurgitating the definition. Okay, number 12. So here we are. We're looking at M right here. And then M goes to N. So you can see that M starts at a vertex. It goes across the triangle. Well, that N is not in the middle. And so that means it's not a median. It does not make a 90-degree angle, so that means it's not an altitude. So number 12 would be neither. Okay, so it would be neither. Now, why would that be? I would say something like this: because n is not perpendicular or in the middle. If it was perpendicular, we would see the 90-degree angle mark, which would make it an altitude. If it was in the middle, we would see the congruent mark, the tick marks, to make it a median. Okay. Number 13, we're talking about MN. Now this one, it tried to trick you because MN, if we started it at M and we went to N, that might mess you up. But let's look at it backwards, and that's okay to look at it backwards. You don't always have to go with the order of the letters. So even though it says MN, let's look at it this way: N. So N, if you notice, let's pretend that's the starting point. Well, it starts at a vertex. It goes across the triangle to the opposite side, and it makes a 90-degree angle, so that makes it perpendicular. So that means this one is an altitude. All right? Because, well, how would we explain that this is an altitude? All right? So it's because it starts at a vertex and is perpendicular with the opposite side. Okay, and that is how we define what an altitude is. An altitude is a line segment that starts at a vertex, that's a corner, and then it has to be perpendicular with the opposite side. That means we're going to see the 90-degree angle. All right, flipping the page over, number 14. Number 14, we're doing the same. We're describing if A to B is a median. Is it an altitude or is it neither? Okay, so A to B, right here. So let's start at A. That's a vertex. It goes to B. B, as you notice, is a point. It's right in the middle, as indicated by those congruent marks. So that makes number 14 a median. Okay, why is it a median? Because starts at a vertex, and goes to the middle, or it ends, I guess, to the middle of the opposite side. Once again, I'm just stating what the definition is of a median. Number 15. So we have number 15. We're always looking at A to B. So here's A to B, and this one is a little bit weird because A to B is outside the given triangle. But where does A start at? Well, it starts at a vertex, and then it goes down and it makes a 90-degree angle. Now, it doesn't make a 90-degree angle with the actual side of the triangle, but an extension of the side. So this would be an altitude. Okay, so number 15 is an altitude. How do we know it's an altitude? Because starts at a vertex and is perpendicular to the opposite side. Okay, and the lights just went out in the classroom. That's a bummer. Hey, but I already had the lights on my camera, so I'm planning ahead. I actually learned something when I was a Boy Scout. All right, for those, I was a Boy Scout for like 2 days. Number 16, but I learned to plan ahead. Be prepared. That's the Boy Scout motto. Number 16. All right, A to B. So here's A, here's B. So once again, where does A start at? It starts at a vertex of the triangle. It goes across the triangle to the opposite side, and it's a 90 degrees. So that makes that an altitude. All right, I'm not going to write the reason why, because the reason for number 16 would be the same reason as number 15. Number 17, so here we have A. We have A starting at a vertex of the triangle. It ends at B. Now obviously that's not 90 degrees, so it's not an altitude. Okay, and is B in the middle? Well, that's a 2, that's a 3. Those aren't equal, so it's not in the middle. So it's not a median. So that means number 17 would be neither. Okay, and the reason, I'm not going to write the reason. You want to write it, but the reason for number 17 would be the same reason as what I put for number 12 in the prior problem. All right, moving on. So now we skipped a bunch of problems and we picked it back up at number 27. or 26, excuse me. So, and then you had to do 26 through 30, which was you were finding the value of x in each one of the problems. Okay, so if you notice in number 26, and actually all the problems, we always have a line right here, which is called a mid-segment. Remember, a mid-segment is a segment that connects two midpoints in a triangle, and we know both of those points are midpoints as indicated by the congruent marks. And then we have a third side of the triangle, and the third side of the triangle would be this side right here, which is indicated by 2x. So we have a mid-segment, which is 6, and then we have the third side of the triangle, which was 2x, okay? And the rule was that the mid-segment was always half as long as the third side. Okay, so if I were to solve for x here, what I have to do is I have to take the value of the mid-segment, and I have to make it equal to the value of the third side, but they're not equal because the mid-segment's half of that. So that means I have to multiply the value of the mid-segment by 2 to make them equal. Okay, so that would give me 12 is equal to 2x, and then I would divide both sides by 2. So in number 26, x, the value of x would be 6. Moving on to number 27, we're going to do the same idea. So we have this mid-segment right here. Once again, a mid-segment is a segment in a triangle that connects two midpoints. And then we have the third side of the triangle, which is right here, which is 36. So to solve for x, I would make an equation. So the equation would be I would take the mid-segment, 6x. I would have to multiply it by 2 to make it equal to the third side, which is 36. Okay, and the reason why I'm having to multiply by 2 again is because the rule is the mid-segment is half as long as the third side. 2 times, and I would solve. 2 times 6x is 12x. 12x is equal to 36. Dividing both sides by 12, the value of x would be 3 in this case. Okay, and then what you want to do when you get these problems is go ahead and plug that answer in or substitute it in and see what happens. So look, if x was 3, 6 times 3 is 18. And now look, I did it right. Is 18 half of 36? Absolutely. Okay, over here, going back to number 20, it's 26. If x is 6, 2 times 6 is 12, and if you notice, is 6 half of 12? Heck to the yeah. So I did it right. So that's how you can plug your answer back in to check your work. Always a good idea to do that. Number 28. All right, so we're going to use the same concept. We have 3x. So what is this segment 3x called? A mid-segment. No one answered because there's no class here. Okay, and then this side, what do we refer to the side of 30 as? That's the third side of the triangle. Okay, so those aren't equal. So what do I have to do to make them equal? So once again, I take the mid-segment, which is 3x. I have to multiply it by 2, and then it's going to be equal to the third side, which is 30. 2 times 3x is 6x. That's equal to 30. I divide both sides by 6. X is equal to 5. Okay, so let's check our answer, see if it makes sense. Substitute 5 in the place of 3. 3 times 5 is 15. Does it make sense? Is 15 half of 30? Yeah, it is. Okay, hopefully you're getting the idea. We get to number 29. A little bit more detailed than 29, but the same concept. All right, so we have this side right here, so we know we have a midpoint. So we connect the midpoint. What is that segment called again? You're right, a mid-segment. Once again, nobody answered because I'm talking to an empty classroom right now. And then we have the third side, which is denoted by the length of 18. Okay, so what do I do to solve for x? I have to create an equation. I'm going to take the mid-segment, which is 2x plus 1. I have to double it. So I'm going to multiply it by 2, and then that's going to be equal to the third side. And then I solve this equation out. Now, when I solve this equation out, I want you to watch this. Most students, some students, not all, would distribute the 2. Okay, that would not be wrong, but I'm just going to divide by 2 right away. Okay, and the reason why I'm going to do that is because that just conveniently cancels out those 2's, and 2 goes into 18 to make 9. So you can do that. Then we could just drop the parentheses. And if you distributed the 2 and got 4x plus 2 equals 18, you're going to get the same answer I'm about to get, I hope. I would subtract 1 from both sides of the equations to cancel out the 1's. Create the equation 2x is equal to 8, and then we would divide by 2. We're using the opposite math operation always to eliminate a value to get our answer. So x would be equal to 4. Okay, so now let's see if it makes sense. Let's take the number 4, substitute it in the place of x. That would make this 2 times 4, which is 8. 8 plus 1 is 9, so the mid segment is 9. Is 9 half of 18? It is. I did it right. Last problem that was assigned to you, number 30. Same concept. I have a midpoint, and I have a midpoint, and I connect them to make a mid-segment. And then I compare that mid-segment to the third side of the triangle, in other words, the side that it's parallel to. And the rule is you have to double the mid-segment. So 3x, you got to double it, so you multiply by 2, and then it will be equal to the third side of the triangle, 21. Okay, 2 times 3x is 6x, and I know why whoever wrote this problem, wasn't me, did this. To solve for x, I'm going to divide by 6, and then, now if you notice, when I divide 21 by 6, I do not get a nice, friendly, easy whole number. Okay, so I'm going to get a decimal. Big deal if you get a decimal. Don't freak out. So this would be 3.7. If you divided it out, you're going to get 3.6. No, that's not right. I didn't do that right. I just did it in my head. 6 goes into 21 3 times. It would be 3.5 exactly. My bad. Okay, sorry. I got excited there. Heck, I could have checked it. So I'm going to say x is 3.5. So now let's see if it's right or not. So let's substitute a 3.5 into here. So that would make this mid-segment 3 times 3.5. That's 10.5. Is 10.5 half of 21? Yeah, it is. Think in terms of money. If you had $10.50 and you added $10.50, that would give you $21. So it's half. So there we go. There's my there's the entire assignment. You didn't have to do any other problems. Okay, enjoy, study this. Okay, and come to me if you got any questions.